In this video, we are going to talk about resultant vectors and vector operations. Well, let's consider these two vectors. Now, to find the resultant of these vectors, we can join them like this from tip to tail, and we can draw the resultant vector, which is a plus b, as like this. So this is the figure up to scale. So a plus b here is the resultant vector of a and b. Now, this method is called as triangle method, which is tip to tail. We join the vectors tip to tail, and then we draw the third side of the triangle as the resultant vector. So what you have to take care here is the direction. It is from A to B, so we are going on this direction, so it should be kind of going to the same direction like that. So from A to B. We can also find the resultant vector using another method, which is actually called as the parallelogram method. Now here we join the tails as in the figure. Now here what I have to do is I have to kind of draw the same vectors so that I have a parallelogram here, as you see, and then draw the resultant vector of a plus b as the diagonal of this parallelogram. So up to scale drawing is here. So you see, we just complete these sides of the parallelogram, and then we draw our resultant vector. So this is called as the parallelogram method. Well, we use parallelogram method if we need, or if the vectors are given in standard form, meaning they are given on the coordinate plane where the tails are in the origin, in 0, 0 position. So then we can find the resultant vector by using parallelogram method. Otherwise, we can use the triangle method for sure. The resultant vectors for A and B are the addition of vectors. So the operation is addition here. But practically, we can also subtract vectors. But what we have to do here is we have to find the opposite vector of the given vector so that we can add them. As we know, plus and minus together makes minus. That's how we get to A minus B. Before going any further, let me mention zero vectors. Now, if you have a vector A with the given direction, minus A will be the same magnitude but in opposite direction. So if you happen to add them, if you want to find the resultant vector, then either in triangle method or parallelogram method, you will join them somehow and get 0. So this is the 0 vector. Going back to our vectors, let's try to find the resultant A minus B. So first of all, we should have the vector minus b, which is the same magnitude in opposite direction, like so. This is minus b here. Now, if we join these vectors tip to tail or tail to tail, we can find the resultant vector. Let's do that. So if we move a little bit, then we have tip to tail position, and my resultant vector will be here, showing the same or similar direction to negative b. Now this will be A minus B. Well, when it comes to finding resultant vectors, it is not only the addition of vectors given. We can have multiples of the vectors. For example, if we are talking about, say, 2b as a vector, then we can add the same vector tip to tail as trying to find the resultant vector. So we have our vector 2b. So it's just that twice the magnitude with the same direction. Well, if it's 3b, you add one more and get 3b. If it is half b, for example, then you have to make it shorter. You have to make half the size of the given vector. Or maybe you have, say, minus 2b. Well, here I have this vector 2b, just that the direction will change. It will show the opposite direction with the same magnitude. So that's how you multiply vectors by a scalar. So, for example, if we have x and y as vectors, then 3x will be, for example, a vector like this. 3 times the magnitude with the same direction. And if we are asked to have minus 3 over 4 times y, it may be something like that, a little bit smaller and in the opposite direction. So if we are asked to find the resultant vector of 3x minus 3 over 4y, then all we have to do is to find the vectors 3x and 3 over 4 times y as in here, and then join them and find the resultant. Well, here we use parallelogram method, which the resultant is here as 3x minus 3 over 4y. Well, this is how we represent the vectors and find the resultant vectors accordingly.